Math 230, Cuesta College. I'm Joe Vasta, and today we are covering Section 3.2 Truth Values. Before we get into it, let's take a look at our puzzles for the day. There are 3 errors in this sentence. So go ahead and find the 3 errors. And what's significant about this sentence? So these are 2 different puzzles. Was it a car or a cat I saw? So there's something unique about that question. So those are the puzzles. We'll get them at the end. Let's go ahead and look at truth values. Okay, so it starts off pretty simple today. The truth value of a simple statement is either true or false. This is a calculus class. Well, what they're going to have you do in your homework is analyze these statements and find the truth value. So this is a calculus class, happens to be false. Okay, our next statement, 9 is a prime number. 9 is a prime number. True or false? Okay, so we have to know what prime numbers are. Prime numbers. Those are numbers that have exactly 2 divisors. So our first prime number happens to be 2. Okay, 1, sometimes people go, 1's a prime number, but only one thing can go into it, and that's 1. But with 2 things can go into it nicely when you divide 1 and 2. 3 is our next prime number. 4 is not a prime number because it has 3 things that can go into it, 3 divisors, 1, 2, and 4. So our next prime number that goes on the list is 5, but not 6, 7, not 8, so there's no more even numbers on this list, because 2 will go into them, and so will 1, and so will the number itself. So the only even number on the list is the first prime number, which is 2. Some people say that 2 is the oddest prime number. Okay, that was supposed to be funny, but no one seems to be laughing. So 9, should 9 go on the list? And the answer is no, 9 should not go on the list, because there are 3 things that can go into 9 nicely, which would be 1, 3, and 9. So 9 does not go on the list. So our next prime number, if you care, 11, you should care because they might ask more questions like this in the logic. Then 13, but 15 does not go on the list because 5 goes into it, and so does 3, and 1 and 15, so the next one is 17, 19, 23, and the list goes on. Okay, the funny thing about prime numbers is the gaps between prime numbers get bigger. So people used to think, well, maybe they run out. But there's actually a math proof that shows there are infinitely many prime numbers. So the gaps might get a little bigger, but there's infinitely many of them. And prime numbers are used in cryptography, public key cryptography, and other places as well. So they are important things in math. But for this question, 9 is a prime number. That happens to be false. Okay, now, before we move on, I might want to add this note. When you take the test, we're going to be writing lots of T's or F's. And I've seen, when I've graded tests, people go, well, I don't know what it is, so I'll go like that. And then I'll say that it was whatever I wanted it to be. This I'll never accept. So you got to make your T's and F's obvious, and you can't do stuff like that. Okay, let's move on in this truth value discussion. Okay, so we have truth values of simple statements. Now we're going to look at truth values of compound statements. The truth value of a compound statement is either true or false. This value depends on the operators and the truth values of the simple parts. A truth value displays relationships between truth values of statements. So a truth table displays the relationships between truth values. So we're going to be looking at truth tables and truth values of compound statements. And that is where we're going to go. So we have to take out our example. We're going to use this a lot. Example with P and Q, where P is I have a penny in my pocket, and Q is I have a quarter in my pocket. And what we're going to do is we're going to analyze the truth values of conjunctions, disjunctions, and negations. So let's go ahead and take a look at this. So I'm going to go ahead and use a ruler here. And we're going to analyze this. That smeared a little right there. So here's statement P. Here's statement Q. What I'm doing right now is I'm constructing a truth table. And I want to analyze this statement right here. P, there's the cap, there's Q. So what does this really say? This says P and Q. Or it says I have a penny in my pocket and I have a quarter in my pocket. Or you can shorten it and say I have a penny and a quarter in my pocket. Okay. Well, it could be the case that I have a penny in my pocket is true. So I have a penny in my pocket, and I could also have a quarter in my pocket. So that statement, Q, is true. So if I have a penny in my pocket and a quarter in my pocket, and I go up to you and say, I have a penny and a quarter in my pocket, am I telling the truth? And the answer is, yes, I am. So true and true gives me a true. So we're going to actually learn logic arithmetic today. Kind of like when you learned 1 plus 1 and the answer was 2, we're going to do it like this. True and true equals true. Let's go ahead and do some more. It could be the case that I do have a penny in my pocket. That is a true statement. And I have a quarter in my pocket is false. Okay, so there's a penny in my pocket. And there is not a quarter in my pocket, okay? And then I come up to you and I tell you, I have a penny and a quarter in my pocket. Did I lie to you? And the answer is, yes, I did lie to you. I was not telling the truth. So P and Q happens to be false. Okay, so true and false equals false. Okay, let's continue this little scenario. P is false. That means I do not have a penny in my pocket. Q is true. I have a quarter in my pocket. So, like if I don't have a penny in my pocket and I have a quarter in my pocket, and I come up to you and say, I have a penny and a quarter in my pocket, was I lying to you? And the answer to that question is, yes, I was. So false and true equals false. Okay. Is there any other situation that we did not cover here when labeling P and Q with trues and falses? Well, there's that situation where both of them are false. I have a penny in my pocket is false. I have a quarter in my pocket is false. My pockets are empty. And I come up to you and I say, I have a penny and a quarter in my pocket. Was I lying to you? And the answer is, yes, I was lying to you. So false and false give me a false. And so this right here, what we just constructed, is the truth table of the conjunction. Lots of logic books and math books will just say, here is the and this is how we define truth for and they'll call this truth table here a definition. Okay, so that's what some logic books will do. Let's point out one other thing. I've seen other logic books define the truth value of the conjunction like this. It is true only when both P and Q are true. So they can actually define the truth values of the conjunction without actually drawing the table. They can say, hey, guess what? It's true only when both P and Q are true. Otherwise, the conjunction's false. And you can see that the only time it is true is when both of them are true. Okay. Some people don't like this part that I put here. They'd rather just look at the truth table. So there are 4, we'll call them arithmetic facts that you have to know so far about logic. And these are things that you should try to memorize because it will help you go efficiently when you do your homework and exams. Well, we did the truth table of the conjunction. What do you think we're going to do next? Well, perhaps we will do sort of the same thing and we'll do truth table of the disjunction. The disjunction is the or, the inclusive or. So that's what we're going to do now. So we'll put a blank paper, almost blank, and it has the 2 statements. I have a penny in my pocket, P, and I have a quarter in my pocket, Q. And I'm going to go ahead and try to draw a line here. We'll try not to smear it. And what are we going to do? We're going to put statement P here, Q there, and I'm going to do the disjunction, which is the or, so I'm going to say P or Q. We learned last time that that is called the cup, but we can just say or. Okay. Let's start off like we did last time. So suppose it's true that I have a penny in my pocket and it's true that I have a quarter in my pocket. And I go up to you and I say, I have a penny or a quarter in my pocket. Did I lie to you? And the answer is no. I actually told the truth because this is the inclusive or. It includes or both. So true or true equals true. Okay, so what was the next thing that we did when we were doing the conjunction? I think P was true and Q was false. Okay, so it is true that I have a penny in my pocket. I have a quarter in my pocket is false. So in my pocket there's a penny and there's not a quarter. I come up to you and I say, I have a penny or a quarter in my pocket. Did I lie to you? No, I didn't, because I do have a penny in my pocket. So true or false gives me true. Okay, and that's what it is because I have that penny. The next situation we had is when P was false and Q is true. And so I do not have a penny in my pocket. I have a quarter in my pocket. That's what those mean. And I come up to you having that quarter in my pocket and I say I have a penny or a quarter in my pocket using the word or. I did not lie to you. I was telling the truth. So false or true equals true. The last scenario is P is false, Q is false. My pockets are empty. They don't have pennies or quarters. And I come up to you and I say, I have a penny or a quarter in my pocket. Did I lie to you? And the answer is, yes, I did. My pockets are empty. So false or false equals false. And so in logic books, sometimes they would present this and say this is the definition of truth values for the disjunction, or this is the truth table. So let's write that out. This is the truth table of the disjunction. Remember, the disjunction is the inclusive or, and that's why true or true is true. There is the exclusive or that we didn't study yet. That's either this or that, where the truth table would be a little different. Okay. Some logic books will not put this truth table when they're defining truth values for the disjunction, and they'll say something like the disjunction is false only when P and Q are false. So that kind of sums up this whole truth table just right here. The disjunction is false only when P and Q are false. And so that is what we have. Here's some other things to note now. If you go true or true, that gives you true. It gives you the same thing as if you go true or true. So true or true equals true or true. Well, that's kind of dumb to say. And same with false. False or false equals false or false. But look at this. True or false is true. But if you switch them around so it says false or true, that's also true. So we can say that, we use a different color, that the or is commutative. Just like addition is commutative. 3 plus 5 equals 5 plus 3. Now if we go back and we look at the conjunction, you can also see that the conjunction, the and, is also commutative. So true and false equals false and true. They're both false. And so we can put that on our list here. We can say the and the or. Now it says is. Commutative. Maybe I should put are. Those guys, oh well, we'll just keep it that way. So and or, they're commutative. So we got to make sure we know these facts about the truth values of the or. So now how many arithmetic facts do we have? We have 8 of them. 4 from the and, 4 from the or. Now we're going to go ahead and give you 2 more. So we'll have 10 arithmetic facts that we'll be using today, and it will get a little more complicated than this. For now, let's do the one that we haven't done yet. I have a penny in my pocket, I have a quarter in my pocket. The one that we're going to do now is the negation. Okay, now with the negation, it's different than the and the or. Because the and the or connect 2 statements together. The negation does not connect 2 statements together. We would never go P tilde Q. That is just not what we would do. So I'm just going to go ahead and put one of the statements there, P, and then I'm going to analyze the negation of P. Okay, so what does a truth table look like when it just has one letter? Well, there's only 2 things that can happen with statement P. It could be true, it could be false. Well, this is going to be really dumb, but I'm going to go through it anyway. So if it's true that I have a penny in my pocket, and I tell you I do not have a penny in my pocket, then I lied to you. So not true is false. And these are things that you could have told me before even taking this class. If I don't have a penny in my pocket, because it's false that I have a penny in my pocket, and I come up to you and I say I don't have a penny in my pocket, then I told you the truth. So not false equals true. So this right here is the truth table. Of the negation. Which is pretty simple. I mean, so I say there's 10 arithmetic facts from logic that you have to know, but these ones are super easy. Not true is false, and not false is true. Notice this truth table only had one letter and has, I'm going to call these rows, it has 2 rows underneath the header row, so there are 2 rows. The other truth tables that we looked at, they had 2 letters and they had 4 rows. We'll talk about that when we start cranking out truth tables later on in this video. Okay, so what are we to do with all these facts? Well, hopefully you start memorizing these facts. Logic is very, very important. It's not just math people who do logic. The better your logic, the better you are to defend yourself. Okay? Lawyers use logic. There's logic involved when you're looking at contracts. So this is very important stuff, and for some of you this will be the most important thing that you learn in the class. And hopefully this will stick with you. The stuff we're doing now seems a little silly, but when we get to the conditional, you'll see what I mean. Okay, so in your homework you're going to have questions like this. Find the truth value. Find the truth value. So that just means true or false. That's what they're really saying here. And this is just memorization. True or false. So go ahead and maybe you can pause the video and do these 5 problems. Okay, true or false, we can look that up on the table. That's going to be true, and that you want to get away from looking things up on the table. These are the ones that people get confused with. So, let me just go back to the conjunction. Okay, so, well, let's do the disjunction first. So, that's what we had here. We had true or false. True or false is true. Okay, so we saw that on the table. Let's take a look at this. The and, just remember the and is strict. He has 2 buddies. So P and Q are his buddies. And when they're both telling the truth, that's cool. But if P is telling the truth and Q is lying, if one of them happens to tell a lie, even though the other one's telling the truth, and says, forget you guys. That's what the F is for, really. So like when one of them is lying, he's, oh, forget it, forget it, forget it. So and is strict. Sure, that makes P feel bad when he's telling the truth and Q is lying, because and's all like, forget you guys. Now, this is how I remember them actually. Or is not so strict. Okay? It's a cup. It wants to give you some water when you're thirsty. It's not strict, because look, when both of his buddies are telling the truth, he's all like, yeah, that's cool. When one of his buddies, like P, is telling the truth and the other buddy is lying, he's all like, okay, it's alright. So, you know, P is lying and Q is telling the truth, he's all, okay, it's alright. I still love Q. It's good. But everybody has their breaking point. And so does the or. When both of his buddies are lying, that's when he says, okay, I've had enough, forget you guys. And so that's how I remember them. So look at this. Here's the or. One of his buddies is telling the truth, so he's all, okay, that's cool, guys. It's just a way of remembering these things. Okay, so now, what is the truth value of false and true? And's the strict one, and so that's going to be false. Okay, now things get a little weird, and they're going to get weirder in the next section in terms of the phrases we say. This planet is Venus. So let's analyze this planet is Venus, and 1 plus 1 is 4. Okay, this planet is Venus. False statement. So that's a simple statement that we're analyzing, and we say that it's false. Then we have the and. 1 plus 1 is 4. That's also false. So look at this. This planet is Venus, and 1 plus 1 equals 4 really comes down to false and false, which equals what? A false. So in logic, you could connect any two statements together with the and. Now, would you go out and say this to your friends? Probably not. You wouldn't say, hey, guess what? This planet is Venus and 1 plus 1 is 4. People would laugh at you. But this is what we do in a logic class because we're practicing the truth values. So when you do get things that make a little more sense, then you can analyze that. So watch this, the next one. This college is Harvard, or 3 times 3 equals 9. Okay, this college is Harvard, or 3 times 3, did I say 3 plus 3? I hope I said 3 times 3 equals 9. Okay, this college is Harvard happens to be false. 3 times 3 equals 9 happens to be true. And so look what we have. We have false or true. So instead of getting emotionally attached to, like, you know, some of you might be in Harvard, oh yeah, isn't that on the other coast? And, you know, you might be starting to get, you know, your feelings are coming into this. No, no, no. You just analyze the truth value of that simple statement. Write the false, write the or, write the true, and then just go with your rules of logic. The definition of false or true happens to be, well, or's not as strict. It is true. So that's a statement that's true. You can go up to somebody and say, this college is Harvard, or 3 times 3 equals 9. That is a true statement. Now, why you would say that to somebody, I mean, you're not going to have many friends, but that one is a true statement. Okay, this last one, here's the and, so we'll put the and there. It's the strict one. 3 is a prime number. Well, if you go back and look at that list, or maybe you just remember, you can see that that one is true. Okay, because and is strict, we're still not out of the woods. We have to analyze this one right here. This is math class. Although it doesn't feel like math class because we are writing a lot of sentences, it's still math class, so that's true as well. True and true equals true. And that's how you play the game. That's what you're going to be doing in your homework. You're going to be finding truth values of statements. Okay, let's go ahead and do some problems that are going to ask the same thing, but they're going to be a little bit different. Okay, so here's 3 problems on one page. Hopefully that wasn't a mistake doing that. And it says, find the truth value. So here's statements here. Now, it's not saying anything about this planet is Venus or this college is Harvard. We don't know what statement P and Q are. But they're telling you that P is false and Q is true. And so for these problems, that's what it is. Now, in your homework, it might say P is true and Q is false, or they might both be false. So we are supposed to analyze this, knowing that. And so what I'm going to do is start off with this one. I'm going to say this one equals not. I'm going to replace the P with a false, and the Q with the true. This is starting to look like algebra class. Remember, x is 5 and y is 3. And then wasn't there like an expression and you put 5 and 3 in there and figure out what it is? Well, when you did that and there were parentheses and negatives and pluses and minuses, you had the order of operations. We talked about order of operations with logic. Well, now we're going to do it with, oh wait, we talked about it with set theory. Now we're going to do it with logic. So here are your order of operations. Parentheses. That's the strongest one. That's what you do first. Guess what you would do next after parentheses? Well, you would do negation. That's next on the pecking order. And then you would do ands and ors. And in this class, we'll say you would do those from left to right. Okay? Now, sometimes there's different conventions, but this is how we're going to play the game here. Does this remind you of the logic? It should. What happened in logic? You did parentheses, then you did what? Complements. Now, what was a complement in set theory? In set theory, the complement was a not. Wow. Okay, so those hook together nicely. And then you did intersection and union from left to right. Intersection being and, union being or. Set theory is built on logic, and you can see that. I'm not going to put the other one, please excuse my dear Aunt Sally, because we don't need to see that. So now that we have order of operations for logic operators, let's go ahead and do this. So, the first thing you would do is the parentheses. False or true? Well, false or true happens to be true. So we replace that parenthesis thing with true, and then there is a tilde in front of there. And then you're going to say not true. Not true is false. Okay. Why don't you pause the video and see if you can do problem number 2 and maybe even problem number 3. Okay, problem number 2. The first thing you do is you write out what P and Q are. So this is not, P is false. So not false, and Q is true. Okay, your order of operations says you do the negation before you do the and. So what is not false? Not false is true. So we replace that with the true and true. True and true equals true. There's the answer. So this one looks a little bit more complicated. Let me write up here order of operations. Order of operations. Okay, I'm going to replace the P's with falses and the Q's with trues. So false or true and false or not true. So all I did was replace those letters with what they told me they were. Okay, parentheses. So I could be working inside these parentheses independently. The first set of parentheses, let's go ahead. I think I will color code this one. It's a little bit more complicated. Is a false or true. False or true equals true. We have the and here. I'm doing inside these parentheses, and the first thing I do within the parentheses, okay, so if this was just its own little problem, the not is stronger than the or. So I'm going to replace the not true with a false. Okay, I still have to finish up those parentheses, so I was kind of doing these parentheses independently. So that first true stays right there. True and. Now I'm going to go ahead and simplify what is false or false equal. False or false equals false. And I'll be done with the colors now. So our very last step is to analyze true and false. True and false equals false. Remember, and's a little more strict. He won't let he won't allow any of his pals to lie. So false is the answer. So some of you are saying, well, I can just do these problems flipping a coin. Well, you'll get them correct probably about 50% of the time. And also on the exam, we like to see the work shown. So make sure you show the work. Another comment that people would say is, well, Joe, this is stupid. This is dumb. This is worthless. And my reply is, you're in a math class. What did you think was going to happen? You were going to see something that was useful? Ha! Actually, this really is useful. We will analyze something in the next section that has to do with a lawsuit. And because we are learning logic, we can see if someone broke the contract. And that's going to be very, very interesting. So we're still doing things. We need baby steps before we get to that. And these are the baby steps. Okay, also logic really is essential to life. Why did I say that? But it is. I mean, you know, you have your logic down, you'll be more confident. People won't take advantage of you as much. Okay, look at this. True or false is really what the question is. But let's see what we have here. We have, suppose Bob is crazy is true. And Bob likes math is false. True or false? Bob is not crazy or Bob likes math. So we're analyzing this based on what the simple statements have in terms of truth values. So what I'm going to do is I'm going to call this Bob is crazy statement, I'm going to call it statement C. And Bob likes math, I'll call that statement M. Okay. I could have called this P and this one Q. I really wouldn't want to call the first one B for Bob because Bob's in this one and I might get confused. So I picked crazy and math as the characteristics for my letters. Okay, so the letters are open to whatever you want to call them. So what I'm going to do to analyze this, and some of you might be able to analyze this without going to the letters, but when we get a more complicated one, then the letters will always work. So now I'm going to write this statement, which is in words, in symbols. Bob is not crazy. There's not crazy. Or Bob likes math. So that's the statement right there in symbols. So now what am I going to do with this statement in symbols? I'm going to make a replacement because it said that C is true. I was just using this as an excuse to put color into this, you know, because people might say, this guy, he doesn't use color that much. I did a lot on the last page, but you know, there's more. Okay, M is false. So that's what I'm going to do. I'm going to place that in there. So watch this. This is not true or false. So now I'm doing a problem like from the last page. I have to use my order of operations. So negation is stronger, so not true happens to be false. Okay, so this not true became a false, and then I'm going to go false or false is false. So Bob is not crazy or Bob likes math is a false statement. And once again, this kind of problem will become more interesting when we hit another operator, which is called the conditional. That will not be done in this section. That's the if-then, and that's when it starts getting super interesting. Now, the conditional is not a fundamental operator. There are only 3 fundamental operators. That would be the and, the or, and the not. This time I'll use are instead of is. And or not, those are called the fundamental operators of logic, but I'll just say fundamental operators. That means there's other operators like if, then, either, or, because, since. All the other operators can be built using these 3 guys. It's like these are your building blocks, and they can build anything from logic. So that's why we are spending a whole section learning the truth values of those guys, because they really build everything else. Okay, the rest of this lecture is going to be constructing truth tables for statements. Okay, and we'll see this in the next few sections. This is an important thing. If you've had a logic class, you probably did truth tables. So here it goes. Construct a truth table for this statement here. Now I have to warn you that truth tables are going to be easier if you have lines. So I made some lines on this paper, so if you have line paper you can see if you can do some of these. And the first thing you want to do with truth tables is draw a line at the top. I want that one to be thicker. And what we want to do is we want to look at all the different letters we have. So we have a P. We also have a Q, and you want to put them there. Okay, so remember when we did the truth table for the and, the truth table for the or, we said, I have a penny in my pocket is true, I have a quarter in my pocket is true, and we did that. And we did exactly what I'm writing here. So let me just highlight this part. Whenever you have 2 different letters in a statement and they ask you to do a truth table, you'll always start off like that. You have to put all 4 of the situations. So, can you put these 4 situations in any order? The answer to that question is yes. But people are going to hate you if you do. Like you could put false, false, and then true, false, and then true, true, and then false, true. You might even start hating yourself, because if you're doing your homework and you look at the answers, I will always write them like this. Now let's notice a little pattern that I didn't point out, because this is going to help us when we have more than 2 letters. Look at this column here. What happens with the trues and the falses? They alternate by 1. So it goes true, false, false. What happens over here? Well, it says true, true, false, false. Now they're not really alternating. But we can use our imaginations and say if this was going to continue, you might expect to see a true, true, false, false, true, true, false, false. So we can say, even though this is using our imaginations, that the first column is alternating by 2s. Okay. This is going to help us with 3 letters and more, but we just want to point that out right now. The next thing we do once we have this established is we look at our statement and say, if we were building this, how could we build this? So we would go back to our order of operations. Who's stronger, the or the not? The not is stronger, so you're going to make another column called not Q. Okay, so now you've got that built. Now you're going to build the whole thing, because now you can OR the not Q with the P. So my next column is going to be the whole thing, P or not Q. And so basically when they want you to construct a truth table, we have to fill out trues and falses on those next 2 columns, and then we'll be done. So watch this. Not Q. How do I do that? I go over to the Q column and maybe I should use 2 hands and 2 pins. I say not true. Not true is false. Not Q. So not false is true. Not true is false. And for some of you, I'm going too slow actually, and not false is true. So that's how we do the not Q column. Okay, so we have that established, and now what am I going to do with the not Q? I'm going to OR that, using OR as a verb, that's alright. I'm going to OR that with the P. So I'm now going to use, I'm looking around here, I've got some bugs. I'm going to use some bugs to help me out here. So there's a bug there, there's a bug there. I'm going to do this column, P, or, and then look at this, not Q. True or false. So we got to remember what that is. True or false equals a true. Remember, or is not as strict. True or true. Look at the bugs. That's what I'm focusing on. That is true. False or false. Or even has its limits, so that's a false. And then false or true is true. And that is a truth table. The yellow part is optional. The orange part is optional too, but there's your final column. And sometimes when you're doing things with truth tables, you like to know what your final column is. Okay, so I'll always circle that in orange. That is optional. You don't need to do that. But we'll see some application with that later on in this lecture. So truth tables, there they are. Let's go ahead and do another problem. We are going to do problem number 2. Construct a truth table for this statement right here. So you can pause the video and do that if you'd like. If you're having a hard time getting started, you're like, I don't know what to do, I'm going to totally help you out here. There. That should get you going. Okay, so and anytime you can pause the video, and also I'm sure some of you are pausing the video if I said something too fast or I said something that you had to think about. So in some cases it's good to have these math lectures on video, because you can pause it. In real life you can't pause your teacher. But I think the classroom is cool because you can ask questions and there's more of an interaction. There's no interaction here. Let's go ahead and do this truth table. We have how many different letters up there? 2 different letters. They are P, Q. So let's go ahead and write out our rows. So I'm going to start off with true, true for the first situation. And then I alternate by ones here. True, false, true, false. And then over here I alternate by 2s. True, true, false, false. And we point out that this will be the same anytime I have just 2 letters on my truth table. Okay, now let's go ahead and write out the next columns, the next few columns. So our order of operations tells us to do parentheses first. So my next column is this: P or Q. Now, can you put parentheses around there? Yeah, some of you will and some of you won't. Some of you will, so it kind of matches like this. We're trying to build this structure here. So what's my next column going to be? My next column is going to be taking the negation of this. So the whole enchilada here. So we have negation, P or Q. And there's not going to be any additional columns. So let's go ahead and do this truth table. The truth table, we are going to OR these 2 columns together. So true or true is true. True or false is true. False or true is true. False or false is false. If you look back on this video or on the PDF, this is exactly, like if we don't have this part right here, this is exactly the definition. This is the truth table of the disjunction. Okay, so now the next thing I'm going to do is I'm going to do the negation. So when the negation is involved, then one of the bugs has to leave. I'm going to take the negation of that column there, the column saying true, 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 false. So the negation of that will be false, 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 true. Okay, bug, you can get out of here. Let's see if I can make it walk. Okay, there it is. I really have to work on my special effects. That was pretty stupid. Okay, so like I said, I would put an orange circle around there. There's my final column. Okay, let's continue to do more problems here. This problem is just like the last problem, but we need to do it. We need practice on this. So I highly recommend that you pause the video and you draw out the truth table for this statement, not P and not Q. Okay, so let me start doing this truth table here. Put a thicker line here. Two different letters, so I'm going to write letter P there, Q there. True, true. I always start off that way, and then this one alternates by 1. True, false, true, false. This one alternates by 2. True, true, false, false. Okay, so now let's go ahead and label all the other columns. The negation is stronger in the order of operations than the and. So I'm going to need a negation P column. I'm also going to need a negation Q column. Now that I have those, I'm going to AND them together. Negation P and negation Q. I'll I'll point this out that, look, this is the same thing we've been doing in all the problems with 2 letters. And let's get going with this truth table. Negation P is right there. The bug, he can't see that well, so I had to direct him. So what's a negation of true? True, false, false. It would be false. So what we're doing is we're saying not true is false. Not true is false. Not false is true. Not false is true. Okay, so now we're going to do the next column, which says negation Q. The negation of true, false, false is false, true, false, true. Okay, so now what we're going to do is we are going to AND the last 2 columns together. False and false equals false. Now, AND is strict, remember? One of his friends is lying, he says, forget you guys. False and true is false. True and false is false. True and true is true. Here's the final column. So there's a few things we want to take note of here. We're done with this problem. Okay, that's the first thing. The second thing is, look at these little logic operators. 1, 2, 3. Look at how many more additional columns I had after the yellow ones. 1, 2, 3. So look at this. See this one? There were 2 of them. 1, 2. 2 additional columns. 1, 2. 2 additional columns. Now, that will usually work unless the statement is a little more complicated and has a negation P here and it has a negation P over here in another set of parentheses. Then it won't be a direct relationship with that. You'll actually have less symbols if you count than columns. No, you'll have less columns than symbols. Well, in any case, but it will work a lot of the time, like if you don't have 2 of the same things within the statement. The other thing to note is this fact. So here was problem. I'm going to have to bend the pieces of paper a little. So here was problem 2. And here's problem 1. So what do you notice about, here's the results from 1, here's 2, here's 3. Well, you notice that the last 2 problems that we had, the final column of the truth table happens to be identical. False, 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 true. False, 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 true. Whereas the first one does not look like those. So if your final columns are identical, then we can say that these 2 statements, so let me write this down. Let's just start off with this one. Negation P or Q, this was from problem 2, is logically, we're going to have to move this over, logically equivalent to this statement right here from 3, which is negation P and negation Q. So this is 3. Statement 2 and 3 they are equal to each other. They're equivalent statements, and that is one of the powers of truth tables. Truth tables can help you see if two different statements, they do look different. Look, those have parentheses and that has an or in it, and then these ones do not have parentheses. This statement does not have parentheses, and there's an and. So we can say this, we can say that negation P or Q is equal to negation P and negation Q. I want to check to make sure the video is still running. So what happens when you get your camera from a garage sale? So, yeah. Still running. So we can say these two statements are equal. Why? Because they have the same final column on their truth tables. But in logic, they don't use the equal sign. What they'll use, we're going to tweak it a little, is the double arrow. It's a double arrow, which means logically equivalent. Which means if you actually had something like a statement, like I have a penny in my pocket, whatever, this statement would be the same as saying that statement. And this is going to be very important, especially in the next sections. Okay, so that's one thing to note, is truth tables, we do them. They do seem kind of boring and useless, but we can verify if statements are logically equivalent to other statements, and that's going to help us with logical arguments. We can only do so much in logic, okay, so we're not going to turn this into a logic class a whole semester, but we will have at least the fundamentals. Let's go ahead and do another problem. So that would mean that statement 2 and 3 are not logically equivalent to statement 1. So statement 1 is a different statement. Okay. So let's do problem number 4. Problem number 4, construct the truth table for this. So see if you can do this one on your own. And so the first thing I'm going to do is I'm going to go ahead. Oh, wait a minute. There was one other thing that I wanted to do. I'm going to go back to this. Okay, so sorry. So you already know. Sorry about that. You already know what that one's going to be. I wanted to do something kind of neat here. We already pointed out that we saw these sort of things in logic. We saw the negation in, well, not in logic, but in set theory. The negation in set theory was a complement. So this problem really reminds me of P complement intersect Q complement. Now, if you want to move on in the video and go to when you see number 4, go ahead and do that. But this is just for all the people who are interested in this. So watch this. I'm going to go ahead and draw a Venn diagram for P complement intersect Q complement. I'll draw the Venn diagram right here because I'm running out of space. I'm going to draw the Venn diagram and shade it. So here's the universal set. There's circle P. Circle Q. Let's do this problem really quickly. I'm doing a Venn diagram shading. 1, 2, 3, 4. P complement. So P is 1, 2. Complement, intersect, Q complement. What's not in Q is 1, 4. We put the, oh wait a minute, what am I doing? P was 1, 2, I'm sorry about that. Q, okay, there it goes. So what is in circle Q is 2, 3. I just paused, you know, the camera cut out just like a few minutes ago. Maybe I should just cut this part out. Nah. Okay, so what's in circle Q is 2, 3. Okay, so what do I have here? The complement of 1, 2 is 3, 4. The complement of 2, 3 happens to be 1, 4. That's what I had written there. I was jumping the gun there. And what does this mean if I take the intersection of these guys? I take the intersection of 3, 4 with 1, 4. I end up getting 4, and that tells me where to shade. So then I would go ahead and take out some colors here. And I would say, okay, let's shade right there. Okay, what I want to say is this truth table here that we did and this Venn diagram shading, these are isomorphic, whatever that means. It means there is a connection between these, a strong connection. And I'm going to tell you what this means. Look at this. If it is true that you are in the P circle, and it is true that you are in the Q circle, so where would you be if you're in both circles? You're in region 2, then this tells you false, do not shade there. If you are in the P circle, but not in the Q circle, that would be region 1. Then it tells you false, there's no shading there, or do not shade there. If you are not in the P circle, but you are in the Q circle, that would be region 3. Then it tells you false, no shading. And if you are not in any of the circles, true, shading. So this right here, in a twisted way, is really, in a twisted way. I don't want you to put this on the test when I ask for a truth table, but this is sort of a truth table right here. There is an isomorphism, whatever that fancy word means, between truth tables and Venn diagram shadings. That's what I wanted to point out. And the other problems, we can do the same thing, you know, in problems 2 and problems 1. In fact, problem 2, since those statements were logically equivalent, if we went ahead and did a Venn diagram for P union Q, and then in parentheses with a complement, we would get exactly the same shading, which would mean those two sets were equal. And that's how we showed two sets were equal in set theory. We did Venn diagram shadings to show two statements are equal or logically equivalent in logic. We do truth tables. Okay, so did we need to hear that? Is that going to help you do your homework? Absolutely not. Was that a waste of your life? Sure it was. Okay, let's go do problem number 4. I really wanted to point that out because I thought that was cool. And even if there's just one student in both of my sections of Math 230 who emails back and says, that was cool, then it would have been worth it. Of course, that would only encourage me to do crazy things like that in future lectures, so maybe you shouldn't say that was cool. Okay, go ahead and do a truth table for this one. Okay, I have one letter, which is P, and there's no Q. So we've done this before with that one, where there were only 2 rows, not including the header row. So watch this. You can say true, false. Okay. I'll circle that in yellow because when you have one letter, that's what you'll always write. And look, it alternates by 1. Haha. Let's go ahead and build this up. I'm going to do the parentheses first, not P. I'll put the parentheses around there. And then my next column is going to be not P. This one's going to be kind of a simple thing to do. We probably don't need the bug, but I'm going to put it there anyway because it's funny. Or is it really funny? I don't hear anybody laughing, so it's not. Oh, wait, the other bug is laughing. Okay, so negation of P is false true. I'm going to put the bug right here. Actually, this bug is a little jealous. And now we're going to take the negation of this column. So the negation of false true is true false. So my final column looks like that. Okay. Look at your final column and compare it to the original column. They're identical. So you could say that P is equal to negation, negation, P. Does this remind you of algebra? You have a negative and then a negative x, which just gives you the x. So, wow, this is called the law of double negation, and in logic you have to use the double arrow instead of the equal sign. And there it is. Now, do you have to do that when you're doing your homework and go, oh, we just proved something? No, we just do your truth table. Okay, this one had how many letters? One letter, which means there were 2 rows. Now I know what you're thinking. You're counting 3 rows. 1, 2, 3. But we're not going to count the header row. So there are 2 rows. When we have 2 letters, how many rows did we have? 1, 2, 3, 4. So 2 letters give 4 rows. So take a guess what 3 letters would give. And this has everything to do in terms of the connection and the answer with Venn diagrams. If you had 3 sets, how many regions did you have? You had 8. So there will be 8 rows when you have 3 letters. Look at this. It says 2, 4, 8. That's a geometric sequence. The next one would be 16. So if you had 4 letters, there would be 16 rows. Those are more of the challenge problems. So let's go ahead and do the next problem. I think we have like 2 more problems to do, and then we'll end this lecture here. So look at this. There are 3 letters now, and with the 3 letters, we said 8 rows. So that's going to be our first challenge, is figuring out the configuration there. So we'll start like this. And we're going to put those letters right up here. We like to put them in alphabetical order. It's convention. P, Q, R. Now I have to get all 8 situations. True, true, true is one that we can put here. But if you start going willy-nilly and saying true, false, true, false, false, true, and just start like randomly saying them, chances are you might not get all 8, or you might get more than 8 and have a repeat. And so we want to do this systematically. So I'm going to go to the last column of this right here, and I'm going to alternate by ones. True, false, true, false, true, false, true, false, and I stop after 8. You can count them. There are 8 of them there. The next one that I'm going to go to is the middle column, and I'm going to alternate by 2s. True, true, false, false, true, true, false, false. Okay, then I'm going to go to the first column, and what do you think I'm going to alternate by? This was by 1s, this was by 2s, so a guess would be, oh, alternate this by 3s. But remember, everything's sort of like a geometric sequence when it comes to this, so we'll alternate by 1s, 2s, and this one's going to be by 4s. So this is going to be true, 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 so 4 trues, and then 4 falses. So this can be used every time you have 3 letters. That gives me all 8 situations that can happen with trues and falses. I don't think you can think of one that is not on this list. And look at this list. Within this list, look at this. That's the one we've been doing for 2 letters right there. True, 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 false, false, true, false, false. And then it's also repeated down here. In fact, if you did 4 letters, this would be seen within the list for 4 letters. P, Q, R, S. Okay, but let's not go there. Now let's build up our columns. So we do parentheses first. Inside the parentheses we do the negation, not P. Okay, now let's go ahead and put the or. So this is not P or Q, and I'll put the parentheses up. And then the next one is the whole enchilada. So not P or Q. Then we have and R. Okay, so it's like building a house here. We've finally built the whole thing, but we are using an order of operations and say who's the strongest. Parentheses, the negation was the strongest, and that's why we put that there. Okay, negation of the P column. Well, true, 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 false, 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 false. The negation of that's going to be false, false, 4 falses, followed by 4 trues. Okay, the next thing we're going to do is we are going to OR the column that I just made with Q. Because OR is commutative, that means, you know, P or Q is the same as saying Q or P. We talked about that with truth values. We could, if we want, just say true or false and then put the answer there. I'm going to be a purist and say it the other way around. Okay, so I'll say not P or Q. So watch, false or true is true. False or true is true. And I'm looking right above the bugs. False or false is false. False or false is false. And we have true or true. True or true. True. True or false. True. True or false. True. Okay, now our last column, our final column, would be this guy right here, which is not P or Q, that's this one right here, and it together with the R. So let's do this one. So this is an and. True and true is true. True and false is false. False and true is false. And is stricter, remember, false and false is false. True and true equals true. True and false equals false. True and true is true, and true and false is false. So there it is, our final column. Our final column is right here. Okay, I had to shut off the video. The phone was ringing, and it was just someone from a car dealership, which I didn't know. So anyway, whoa, there is our final column that I circled in orange. True, false, 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 true, false, true, false. And so that's how you do truth tables with 3 letters. So normally I would say let's just end this lecture, but I think we need to practice one more and then we'll figure out those puzzles. So problem number 6 is our last problem that we're going to do in this section. Go ahead and construct a truth table for this very complicated statement. Uh-oh. Whoa, what happened there? That's all right. Now, when I say how many letters we have in this statement, you might say 4. But I mean, how many different letters? Q actually is just one of the letters. So I have in this statement P, Q, and R. So it might be a really good idea if you pause the video to see if you can finish this truth table. Okay, so let's go ahead and do this truth table. R is going to be true, false, true, false, true, false, true, false. Again, there's 8 of them there. Q is going to alternate by 2's. True, true. False, false. True, true. False, false. P is going to alternate by 4's. So you can even make this musical. You could say true, 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 true. And then false, 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 false. Or not. Okay, maybe you don't want to do that. Now let's go ahead and build our columns. What we see here is we do see a not P. And in this parenthesis we also see a not Q. And so we can build up this whole parenthesis and write it as not P and not Q. So that completes this part right here. So it's like we're building a house, we've just built this part of the house. Now I'm going to build this part. Parentheses come first, so Q or R. Now I'll just put those in parentheses. And then what do we do next? Well, the negation is stronger than the or, so I'm going to negate that. Negation. Q. Oh, look at this, how this line came up and it's like totally messing me up now. Or R. I mean, look how high I had to go. Look, I even did that. And then, now I'm going to OR this guy with this guy. So I'm going to do the whole enchilada. So look at this. This is not P and not Q. Or negation Q or R. Woo! Okay, so almost went off the paper. Now, what some logic books do is they'll get a little lazy and they'll like throw an or in between this to try to save from writing this. I find that when I do it that way, I lose a lot of people. And when students do it that way, sometimes they mess themselves up during the exam. So I just write out all the additional columns. 1, 2, 3, 4, 5, 6. Look at the symbols. 1, 2, 3, 4, 5, 6. Now, had this been a negation Q, then I would have counted 7 symbols and there would have only been 6 because I would be using that one twice. But this one doesn't have a negation Q inside the parentheses. So this works out great. I'm going to use the bugs and we're going to kind of get through this quickly. We're going to do negation P, which was 4 trues and 4 falses. And once again, we can go false, 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 false. True, 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 true. Okay, and that's as exciting as this lecture is going to be, is when I do that. Okay. Negation Q. Q is 2 trues and then 2 falses, 2 trues, 2 falses. So this is going to be 2 falses, 2 trues, 2 falses, 2 trues. Okay, now I'm going to AND the last 2 columns that I made. So when I AND is strict. So look what happens. There's going to be a lot of falses here. False and false, false. False and false, false. False and true, false. False and true, false. I'm looking at these guys right here. True and false, false. True and false, false. True and true, true. True and true, true. Okay, now I'm going to OR Q and R. So I'm ORing those guys together. Come on, stop turning. Oh, because there's magnets in them. So look at this. When I let that go, he goes that way. See, the magnets are, oops. So I can stick these to the board. See, there's magnets on them. So if that was freaking you out that they didn't want to face each other, look at that. It's like, I don't like you. But there it goes. Okay. There it is. We're looking at those 2 columns. Okay, Q or R. So true or true is true. Now the or is a little bit more relaxed. True or false is true. False or true is true. And then we have false or false is false. And let's see here. This is true or true. True. True or false. True. False or true. True. False or false? False. Okay, so we've just generated this column. We only have 2 more columns. We're going to take the negation of the column that I just created, which is this one right here. So, well, this is true, 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 false, true, 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 false. So it's going to be false, 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 true, false, 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 true. Okay, the last thing that I'm going to do is OR this last column that I created. See, that's this one right here, with this guy right here, the not P and not Q. So we're going to OR those together and see what we get. We get false or false, false, false or false, false, false or false, false. Then false or true is true, false or false. Lots of falses in this one. False or false, true, or false is true, and true or true is true. And this gives us our truth table here, our final column. So that one right there. How many falses do we see in the final column? There are 1, 2, 3, 4, 5. 5 falses in the final column. Is that equivalent to problem number 5? I'm going to fold the page here. Here's problem number 5. Problem number 5 also has 5 falses in the final column. 1, 2, 3, 4, 5. I believe it does. But are those 2 statements equivalent? No, because they don't have identical columns. So statement number 5 is not equivalent to statement number 6. So I believe we are finished with this section, section 3.2. But before we turn this video off, let's get back to this here. There are 3 errors in this sentence. Maybe you spotted them. Right here, you should be using THERE. There are 3 errors. That's actually not spelled correctly. And I think the problem with this is when you look for the third one, you can't find it. Well, that happens to be the third error in this sentence. So the third one is, third error is that it's untrue. It's false. Okay, because there's only 2 errors in the sentence. So some of you did not like it, and that's why I put this one. This one, was it a car or a cat I saw, is called a palindrome, which means it reads backwards the same way that it reads forwards. So watch this. Was it a car or a cat I saw? So I'm going to put some other ones out, so, you know, in case you were like wondering, what did he say? Palindrome. So here's a good one. A man, a plan, a canal, Panama. Now that's a good one, because you could read it backwards and it says the same thing. There's other ones that we could put on the list like Bob and race car, but those aren't as exciting. Here's another one that I thought was good. A student gave this one to me. Did Hannah see bees Hannah did. Okay, so that one's maybe not as good as the other ones, but it's still pretty good. And what I thought was interesting, there is a city up in Northern California called Wairika. Not to be confused with Eureka. Eureka is on the coast. Yreka is, it's above Shasta, I believe. It's above Weed. There's actually a town called Weed. And they have a sign that says, "We'd love you to come back," or something like that, and they use Weed. But Yreka is above that town. And so I don't know if it went out of business or whatever, but there was a place called the Yreka Bakery. And I thought that was really cool because that's a palindrome as well. Well, this concludes 3.2. You guys have a good day, and I'll see you in the next video.